Have you ever wondered why, for certain circuit elements, like motors and transformers, you're given impedance as a percentage in their rated values on the nameplate? What does the percent impedance mean? What is its significance, and how are we going to use that valuably in our circuit formulas? When providing impedance as a percentage, there are some assumptions being made that you, as the electrical engineer, are expected to understand. Well, what are those assumptions? The first assumption is that as a percentage value, this is actually being represented as a per unit value. So if, for example, it was a 38% value given, well, what that nets out to in a per unit value is 0.38 PU. If it is in fact a per unit value, as we've demonstrated, the first thing you should be asking yourself once you understand that is, well, what are the bases? In a three-phase system, the bases would be the rated total power as well as the rated line voltage. The third assumption being made is that the percent impedance provided is a per unit impedance per phase. It's a per phase impedance demonstrated here. If this is confusing to you, please review our previous videos on the per unit bases, and you'll be more clear on it. Now that we know when impedance is provided as a percentage, that signifies a per unit value with the bases already assigned, sometimes we will find ourselves in circumstances where the bases supplied by that impedance value don't really meet the case of our problem at hand. And what I mean by that, maybe put another way, is in providing per unit impedance, they're picking the bases already for you, and sometimes those bases don't quite satisfy the needs you have for your per unit calculations, which means you're going to have to do some sort of per unit base to per unit base conversion. To convert the given per unit impedance to a new per unit impedance that will help you with the formula, you need to use this formula. So as you go into the PE, make sure you have this formula with your notes along with the other per unit formulas, because you can be asked a PE question where a percent impedance is given, and yet you will be required through some instruction in the problem to use a new per unit value. So you're going to need to use this conversion formula. Just to review now what has been actually written here, if you notice our Z impedance with the per unit subscript, and then we have a further subscript with a 1 and a 0. The 1 is the newest base you're trying to get to. It's the one you're converting to, and the 0 is the original base. In a lot of reference material, you can see this formula written many different ways, with impedance being spelled out, or perhaps the kVAs being given, or so forth. But what we've tried to do here is give you the most condensed, variable-based formulaic representation of it here. Oftentimes, when using this formula, you'll not need to change the voltage and the power bases. Sometimes you can keep them the same as the ones you've selected originally. If that's the case, then all you need to do is supply the same numbers in the numerator and the denominator, and essentially it goes away, like I've demonstrated here in power and in voltage. So you can kind of keep this formula a little bit dynamic to satisfy conditions where the power base doesn't need to be changed, or the voltage base doesn't need to be changed. So let's see this formula in action with some real numbers given. So we'll use what we set up here as the 38% impedance value in our formula. So let's set up the voltage and the power bases. So let's say our original voltage base will be 480, and our original power base will be 3 kVA. Now let's discuss the new voltage base that we're going to work on. So let's establish that, the new voltage base as 208 volts. And let's say the new power base is going to be actually the same as our given original one of 3 kVA. So now we can apply these numbers to our formula. So to analyze this formula really simply, we've just filled in our variables. We have a 0.38 impedance per unit there. We have our 480 volts, which is our original voltage base, put over 208 volts, which is our new voltage base. We square that, and then we are not changing our power bases, so we can put the new over the original being the same. 3 over 3 obviously equals out to 1, which algebraically we obviously know makes that whole parenthesis go away, and we can net out to a 2.0 pu. So it's important to remember that most transformer impedance and motor transients are given as a percentage, which means that they have a per unit value base within that understanding of a percentage. Sometimes those bases that have been chosen for you will not necessarily work for a given problem or situation you find yourself in, and you'll need to convert them to a new per unit impedance. You can use this formula to do so, and if you have watched all of our videos, you have all of the primary formulas necessary to work the entire per unit methodology for PE style problems.